Hi, this is Mr. Anderson. This is going to be a short video with electron model examples. So our last video we were talking about making an atom model, and a couple things to review. We know that the center of the atom is the nucleus. That's where the protons and the neutrons are found. They make up the mass of the atom. Outside of that, we have these rings. These are the orbitals, also known as energy levels or shells. They're where the electrons are found. Electrons have negative charges. Their negative charges, similar to magnets, repel each other, so only so many are found in a space. And the last orbital ring, or energy level, are where the valence electrons are found. These are the electrons that can interact with other atoms to form compounds. So, experiments have found that the first orbital closest to the nucleus can hold 2 electrons. When it's full, electrons start moving out to the second orbital. It holds 8 electrons. When it is full, electrons start moving out to the third orbital. It can also hold 8 electrons. After it is full, electrons move out to the fourth orbital, and it can hold 18 electrons. Now, this is not all the orbitals of the atoms. These are just the orbitals that in middle school we're supposed to learn. Alright, so let's do a couple practice problems together. We already have seen in beryllium where there's a 4, it means we have 4 protons in our atomic number. Atomic number also tells us there are 4 electrons. To find the neutrons, we take the atomic mass of 9. We subtract it by the atomic number of 4, and that gives us 5 neutrons. So, knowing that we have 4 protons, we'll go to our nucleus, we'll put in 4 protons, and we'll put in 5 neutrons. And remember we have 4 electrons, so this first orbital fills up at 2 electrons, and the other 2 electrons would then go out to this second orbital. All right. I'm going to move this down here to remind you that these would be the valence electrons. It would be these 2 electrons that could interact with other atoms. All right, and we can check our work by looking at our periodic table. When we find beryllium, it's in this second column, and there is the Roman numeral 2 up here, which means its valence orbital should have 2 valence electrons. So we go back and check our work, and it does. So we feel pretty good about being correct. Our next problem is nitrogen. We can see the atomic number up here is 7, so there are 7 protons, 7 electrons, and the mass is 14. The atomic number is 7. 14 minus 7 gives us 7 neutrons. So, in our nucleus, we have 7 protons, we have 7 neutrons, and our first orbital for our electrons will fill up at 2, and our other 5 electrons, because 7 minus 2 is 5, would go out to the second orbital. We have to stop and think, can the second orbital hold 5 electrons? Yes, indeed it can. It can hold up to 8. So, now let's check our periodic table and make sure we're right. So let's find nitrogen. And nitrogen is over here. We can find it fast using the atomic number. And it's a V up here. A V in Roman numeral symbols means 5. So it means there should be 5 valence electrons. And that's what we have. Let's try another here. We have this time sulfur. And there's 16 protons by the atomic number. I also know there's 16 electrons. I take my atomic mass of 32. I subtract it by 16. 32 subtracted by 16 is also 16. So let's put this into our model. We have 16 protons. Oops. We also have 16 neutrons. And our orbitals here. Our first orbital has 2 electrons. So 16 minus 2 means we still have 14 to work with. We know 8 will fill up here. So these electrons add up to 10. 16 minus 10 leaves us 6. Now remember here, the second orbital fills up at 8. So these other 6 electrons have to go out to the third orbital. And this orbital can also hold up to 8 electrons. All right, so now our last example is krypton. So in this example, we have an atomic number of 36. So there are 36 protons. And that also means we have 36 electrons. And 84 is our atomic mass. We subtract it by 36, and that will give you 48 neutrons. So now we go and we take that and put it into our atom model here. So we have 36 protons, 48 neutrons. And our electrons here, we know the first orbital is going to fill up at 2. We know the second orbital will fill up at 8. 2 and 8 gives me 10. I still have 26 electrons to work with here. So that means the third orbital is going to fill up at 8 also. And 2 plus 8 plus 8 gives us 18. 36 minus 18 means 18 left. And you know what? That last orbital fills up at just 18. Now there is a little catch here. So if you've been paying attention, you'll notice that this doesn't really work out with our model of checking on the periodic table. Because when we look, there is no 18. Krypton fills up at 8 valence electrons in its valence shell. And the reason why is because this atom, there's actually another way that the electrons split. There's what's called a subshell. So this is one of the few exceptions on our periodic table where our check doesn't actually work out correctly. Okay, but most of them do. All right, so now you're going to go and try the practice problems on your own. Hopefully you feel a little bit more confident. Good luck, and if you get stuck, shoot me a message. Till next time, bye.